Welcome to lesson 2.2, dividing integers. Today we're going to talk about dividing rational numbers, more specifically integers, and understand that integers can be divided provided that the divisor is not 0, and then interpret quotients of rational numbers by describing real-world contexts, and apply properties of operations as strategies to divide rational numbers. Right? So basically what this means is you are going to learn how to divide integers today and how to kind of take that and apply it to real-world situations and how to use different strategies to divide those numbers, right? I know it says rational numbers, but we're focusing on integers for this lesson. All right, so here we go. First, we're going to start with the explore activity. We have a diver who needs to descend to a depth of 100 feet. She wants to do it in 5 equal descents. How far should she travel in each descent? Okay, so let's find those important numbers. 100 feet. She wants to do it in 5. And then we want to equal. So she wants to do it in 5 equal descents. Okay? And descend is important here because that tells us that she wants to get to a negative 100 feet. Excuse me. All right, so here we're going to use the number line to find how far the diver should travel in each of the 5 descents. So if we want to go from 0 to 100 and we want to do it in 5 equal descents, we need to take a look at how we could chunk this up into 5 equal descents. Well, here, if I go here to here, if I do 10, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's too many. She only wants to do it in 5. So if I did 10 feet and it was 10 times, if I double that, so if I do 20 feet, then now that I've doubled it, it should take half as many dives. So now the first one is 20 feet, and that was the first dive. The next one is 20 feet, and that was the second dive. The third one is 20 feet. Fourth is 20 feet, and the fifth is 20 feet. Okay, so that allowed us to get to a depth of 100 by doing 5 descents. Okay, so how far would she have to descend? She would have to descend 20 feet. All right, so to solve this problem, we can also turn it into a division problem. Right? We can set it up as saying we want the negative 100 to be divided by, well, we're dividing it into chunks of, or we're dividing it into 5 chunks. Not chunks of 5. Chunks of 5 would mean she would descend 5 feet each time. We want 5 chunks. 5. Okay, so we can rewrite the division problem as a multiplication problem and think, something times 5 has to give me 100, and that 100 has to be negative. Well, going back to our rules of multiplication, we know that a negative times a positive, or a positive times a positive gives us a positive. We want a negative answer, so our signs have to be different. So since the first sign, since we know the 5 is positive, so since we know 5 is positive, the unknown factor right here has to be negative. Okay, so we know that that number has to be negative in order to get the negative 100. And we know that 5 times 20, knowing our math facts, we know that 5 times 20 equals 100. So using our integer rules, since 5 is positive, that 20 we know has to be negative. So we know that the diver should descend. Now here's the important part. They're not descending negative 20 feet. Descend already implies negative, so they're descending 20 feet each time. Okay, descending a negative 20, again, is like that double negative, the not going to the party. So descending negative 20 would actually mean that they'd be going up, ironically. Okay, to be 100% honest with you, do I think you're going to go back and write this process out every single time? No, but I do want you using your multiplication facts to try and help you figure out the division facts. So looking here, we have 14 divided by 7, and I know that 2 times 7 gives me 14, so I know my answer has to be 2. And then here, I know that since both both of these are not negative, I know that my answer has to be negative. Okay, because again, in order to give me, a positive 14, since 7 is negative, I know that whatever this is has to be negative. And that's a negative sign, not a dot. All right. So then now here, again, thinking about it, I want to know, so 9 times what would give me 36? Then I also have to remember that 9 is negative and so is 36. So since 9 is negative and the answer would be negative, I know that this has to be positive. And I know that 9 times 4 gives me 36 and that the 4 has to be positive. Okay. Then here I know 11 is positive times something has to give me a negative 55. So since the answer is negative and my first number is positive, I know that my missing result has to be negative. So I know it's a negative 5. And then I know that 5 times something gives me a 45. Again, both are negative though, so negative 5 times something gives me negative 45. So since I get a negative, I have to make sure that my answer is positive. So in this case, it would be a positive 9. All right, so let's make a conjecture. And conjectures are that's what I'm looking for, kind of like a hypothesis, so a guess about the quotient of two integers with different signs. So make a conjecture about the quotient of two integers with the same sign. So I want you to make your guess, and when you're doing your self-assessment, there's going to be a spot on there, 2 spots on there for you to answer this. So you need to make your guess and tell me, what do you think you're going to get when the signs are different? And what do you think your answer is going to be when your signs are the same? All right? All right, so now, excuse me, we're going to take a look at the next one. And we're going to try these your turn problems. I skipped the example because I feel like you guys can read and go over the examples on your own, all right? So taking a look at this, I'm actually going to use our counters to go over these problems with you because that seems to help a little bit. So when I have, any 0 divided by anything, so if I'm taking 0 and dividing it into groups of -6, well, I have no pieces to divide out. So that means that my answer has to be 0. You know 0 divided by anything is 0 based on our properties. Now here, I have 38 divided by a -19. So what that means is I'm taking 38 pieces and I'm putting them into 19 different groups. So it's positive though, so here we go, make our huge dots here, 38 of them. So 1, 2, and then putting them into 19 groups. Let me erase. Actually, you know what? Let's do this one instead. Instead of drawing 38 pieces, let's do number 4 instead. So I have -13 and I want to put it into groups of 1. Okay, so and it's negative, so I need a red dot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, but now since I'm putting it into groups of -1, so since I'm putting it into groups of -1, I want the opposite of all of this. So remember we talked about this? So all of these are negative, but since I'm putting into groups of 1, but I want the opposite of what they are, so each one of these is negative, I want them all to be positive. So I made 13 groups of 1 that were negative. I want them to be positive, so I'm getting a positive answer. Right? So again, let's take a look at an example with with positives. like we did before. Let's do even, ooh, that's really large. Let's do 4 divided by -2. Okay, so I have my positives. I have +4, and I want to put it into 2 groups. So 1, 2, 3, 4. So now I've done that. I've put them into the groups of 2, but it's groups of -2, so it's telling me that I want the opposite of each of these groups. So the opposite of these +2's are -2's. Right? So here we go. So really what I can look at is I can use those rules that we use for multiplication and know that if I take my 38 positives and put them into 19 groups, I get 2 in each group. But because I want the opposite of that positive, my answers are going to be negative. Okay, again, we have some examples here of how we're going to pull our stuff apart. So Jake answers questions in 2 different online Olympic trivia quizzes. In each quiz, he loses points when he gives an incorrect answer. The table shows the points lost for each wrong answer in each quiz, and Jake's total points lost in each quiz. In which quiz did he have more wrong answers? Okay, so in this case, like we said, it's important to note that he loses points for incorrect answers, and it shows the points lost and the total points lost in each quiz. So let's take a look at this. So in the first quiz for the Winter Olympics, okay, he loses 3 points for each incorrect answer, and he lost a total of 33 points. So if you take that -33, his total, and divide it by the 3 points lost each time, you can find out that he missed 11 questions. Okay? And in this case, our answer would be positive because the number of questions would never be a negative situation. The number of questions is just exactly that, the number of questions. Okay, so we know that on the first one, he missed 11 questions. Now on the second one, he lost 56 points. And every time he misses a question, he loses 7 points. So those 56 points lost are put into groups of -7 to find out that he missed 8 questions. Okay? So even though he missed fewer points or lost fewer points on the winter quiz, he got more incorrect questions on that quiz based on how many points he lost each time. All right, so let's try this one. A penalty in Meteor Mania is -5 seconds. A penalty in Cosmic Calamity is -7 seconds. Yolanda had penalties totaling -25 seconds in a game of Meteor Mania and -35 seconds in a game of Cosmic Calamity. In which game did Yolanda receive more penalties? Justify your answer. All right, so in Meteor Mania, it's a loss of 5. In Cosmic Calamity, it's a loss of 7. If you're able to, sometimes it's nice to be able to change up that color so you know what goes with what. Okay? Excuse me, so then for Meteor Mania, she lost 25 seconds, but in Cosmic Calamity, she lost 35 seconds. So what I know is, in Meteor Mania, those 25 seconds that she lost came in chunks of losing 5. I know that 5 times 5 gives me 25. And I know that in order for 5 times 5 to give me a -25, that this one has to be positive. So in Meteor Mania, she lost 5, or she had 5 penalties. In Cosmic Calamity, she lost 35 points, but those came in chunks of -7. And when you do that division, she again missed 5 questions. Okay, so our answer here, or the result, would be that she received the same number of penalties in each game. So Yolanda received the same number of penalties in each game. And then your justification is your work. Okay, you could take it a step farther and say that you know this because if you take the 25 seconds she lost and put it into groups of -5, you get 5 incorrect answers. And then if you take the 35 seconds that she lost and put it into groups of -7, you get 5 penalties. I'm sorry, not incorrect answers, 5 penalties. Okay, so you could take that process and put it into words and take that understanding up to that level 4 of advanced. All right, as always, you have your guided practice problems that I would like you to try. All right, you have 19 problems. Again, please make sure that you're answering that last question. It says essential. Essential means that it is important, required, like very, very important to the lesson. So please make sure that you answer those. And again, just try them. Even if you come in and your answer is wrong, that's fine. That gives us something to start from. If you don't answer it at all, that doesn't give us a point to start from. All right? So don't worry about getting it wrong. Worry about getting it done and making sure that you put down what you're thinking. That's what I want to know, what you are thinking. As always, if you have questions, please be sure to write them down or email me so we can go over them in class.